All right, let's take another look at another one that combines several concepts. So we have 812 grams of sulfuric acid are placed with an excess of zinc in a sealed container, sealed evacuated container, or a 3-liter flask as the container. So that means you injected this sulfuric acid with zinc into a container that had nothing else in it except for zinc and sulfuric acid, and it's 3 liters in volume. When the reaction is complete, the temperature of the contents of the flask is found to be 29 degrees Celsius. What is the pressure of the gas in the flask? What is the pressure of the gas in the flask? So right away, you know, we have some kind of stoichiometry because some reaction is occurring here. Are placed with an excess of zinc when the reaction is complete. So we know we have some stoichiometry going on. And we have some gas law business because we're figuring out what the pressure of the gas in the flask is. Do we even know what the gas is? We'll figure it out. So the first thing we know, since we have a stoichiometry problem, we're going to need a balanced equation. So what are our reactants? Zinc and sulfuric acid. Remember, zinc and sulfuric acid react. Zinc sulfate is going to form, and hydrogen gas. Okay, so hydrogen is our gas. So what do we need to know about that hydrogen to be able to figure out the pressure? Well, pressure times volume is equal to the number of moles times R times T. So in order to figure out pressure, if I just rearrange this, pressure is equal to nRT over V. Okay. So I need to know N, R, T, and V. Well, what do I know already? Well, I know V, 3 liters. So I know my denominator. Do I know T? Yeah, 29 degrees Celsius. So T is equal to 29 plus 273. Okay, this is V. So I know T, so I know V, T, and or R, of course, but I don't see anything where I can N. Well, I can figure N out because I got some stoichiometry. So I know 812 grams of sulfuric acid react with an excess of zinc. So I want to figure out what N is. And what are we talking about for N? This is the pressure of hydrogen gas. So I need to find out how many moles of hydrogen. So let's do a quick stoichiometry problem. 812 grams of sulfuric acid. Well, like all good chemists, the first thing I want to do is get this into moles. So I look up on my handy dandy periodic table. I have 2 hydrogens at 1.01 apiece. That's 2.02 plus sulfur, which is 32.1 grams, plus 4 oxygens at 16 apiece. Okay, so I can figure out the molar mass of sulfuric acid. So I have 1.01 times 2 plus my sulfur, which was 32.1, plus 4 times 16, I use my little parentheses here, equals 98.12. So my molar mass is 98.12 grams of sulfuric acid. It's 1 mole of sulfuric acid. Now I'm in business. Oh, I got to balance this equation. Is it balanced? Zinc, zinc, sulfate, sulfate, 2 hydrogens, 2 hydrogens. Okay, so I know that for every 1 mole of sulfuric acid, I make 1 mole of hydrogen gas. So I'm going to go ahead and calculate this. So I have 812, not going to worry about times 1 divided by 98.12 equals 8.28. We're good to 4 sig figs, so 8.276. Actually, it's going to be 2 sig figs. So, well, 276 moles of H2. Well, look at that. There's my N. So I know V, I know N, and I know T. What's 29 plus 273? 29 plus 273. 302. Alright, so let's put it all into here. The pressure is equal to nRT over V. What do we figure out for N? 8.276. 0.276 moles of H2 times R, remember R, 0.0821 liter atmospheres per mole K. Yep, this is in my way here. Times what? The temperature, 302 kelvins, all over, what's my volume? Oh, 3 liters. So pressure is equal to, let's plug it all in and see. Let's see. So we have 8.276 times 0.0821 times 302 divided by 3.0 equals, so pressure is 68. Oops, how many sig figs are we good to? We got 2 here, so it looks like 2 sig figs, so we'll call it 68 liters. I'm sorry, it can't be liters, that's volume. Plus, let's check our units. Liters cancel with liters, K's and K's, moles with moles. We're left with atmospheres. So it's 68 atmospheres. That's pretty high pressure. There you go. That's the pressure inside the flask when we're all done.